for 23, in our cumulative review, we are looking at a very similar problem to number 8. The only difference is we're being asked to solve for x. So when you're adding fractions together, you really need to have a common denominator. So we need to have common denominators. Now the first thing I noticed in this problem is we have the binomial x minus 3, and then over here we have the binomial 3 minus x. We really want them to be the same. That makes our life much, much easier. So to accomplish this, I could multiply this whole thing by -1 over -1. So that will leave me negative 2x over x minus 3. And that's equal to this whole thing here. So I'm going to rewrite this, 2x plus 1 over x minus 3 plus x plus 3 over 2x plus 1. And again, we're looking for what x is equal to. I can put that up here. This is going to be my answer. X equals some number. All right. So now what I want to do is I want to get rid of my denominator. To get rid of the denominator, I have to multiply everything by the common denominator. In this case, the common denominator is going to be x minus 3 times 2x plus 1. So I'm going to rewrite this showing that I'm multiplying everything by my common denominator. So first I'm going to write the problem as it stands, 2x plus 1 over x minus 3. Just to make life easier, I'm going to put this in parentheses so you'll see why I'm doing that in a second. I'm going to provide a space, then I'm going to put my next term. So I have x plus 3 over 2x plus 1, and that's one whole group. Leave a space, is equal to negative 2x over x minus 3. And again, I'm going to put parentheses around it. Now I'm going to multiply everything by my common denominator. And I am allowed to do this because I can multiply, divide, add, subtract, or divide anything I want to one side of an equal sign as long as I do the exact same thing to the other side. I'm just doing it with polynomial expressions now. So my common denominator is going to be x minus 3 times x, 2x. You can't read that. Really want to get that x out of there. Oops. Nothing is more exciting than watching someone erase stuff. One more time. Okay, here we go. 2x plus 1. And I'll multiply the, and I'm not going to worry about the denominator because I'm just multiplying everything by a common denominator. So I'm going to multiply this by x minus 3 times 2x plus 1. And over here I'm going to multiply this also by x minus 3 times 2x plus 1. So before I go through and multiply these things together, it would make my life much easier if I reduce. I cancel out things that can be canceled out. So I notice we have an x minus 3 here and an x minus 3 here. I have a 2x plus 1, 2x plus 1. Notice how the denominators are disappearing. X minus 3, x minus 3. So now I must multiply these out. So rainbows, smiley faces. For those people in traditional algebra courses with that we call that FOIL. So we have 2x times 2x, so we get 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. 1 times 1 is 1. Add them together, so I get 4x squared plus 2x plus 1. For this one, again, rainbows, smiley faces. So we have x times x is x squared. X times negative 3 is negative 3x. 3 times x is 3x. 3 times negative 3 is negative 9. I add them together. These cancel out. So I get x squared minus 9.
Is that the final answer?
No. Then, negative 2x times this mess here. Negative 2x times 2x is equal to negative 4x squared. Negative 2x times 1 is negative 2x. So, once all is said and done, I'm going to have 4x squared plus 2x plus 1 plus this binomial, x squared minus 9, is equal to negative 4x squared minus 2x. So essentially, I've just set all of the numerators equal to each other, and the denominators have canceled out. Yes.
Shouldn't it be 2x plus 2x 4x?
Oh my goodness, 2x plus 2x would in fact be 4x. So,
Oh my god.
it's a wonderful thing to have people around who can check your work as you're doing it. I highly recommend it. You don't have to redo this whole problem. All you gotta do is fix this up here. Thank you. You're perfect. All right. So now, as Ali said, we're going to combine similar terms. So I have 4x squared and just plain old x squared. What is 4x squared plus x squared?
5x.
5x squared. I have no other x's, so I just have the plus 4x. 1 minus 9 is?
Negative 8.
All right, is equal to negative 4x squared minus 2x. So now I really want to, since I have a quadratic expression, I want everything on one side of the equal sign and a 0 on the other. So what am I going to do to get everything over to the left side of the equal sign? Just shrinking it so I have some more room. All right. Yes?
You add 4x squared to...
Add 4x squared to both sides.
Why would you all of this?
So I'm going to end up with 9x squared. Great. What am I going to do to move that negative 2x over? Add 2x. So 4x plus 2x is 6x. And then I just have that negative 8 hanging out. And that's equal to 0. Ugh, this is ugly.
Okay. Should we add 8?
It's not the final answer.
Oh.
Because we are being asked to solve.
Yeah.
To solve,
Wait, you set them each to 0.
to solve a quadratic, two things must be true. You must have a factored form expression, and it must be equal to 0.
Oh, you had 0.
I don't have a factored form expression yet, so I must factor this.
Equals to
So we need to factor this. So we need to figure out a binomial pair that will equal this. And I know that I'm going to have one positive inside the binomial and one negative because my last term is negative 8. So my possible factors for 9, I have 1 and 9 and 3 and 3. My possible factors for 8 are going to be 1 and 8, 2 and 4. So my question is, can I multiply two of these numbers together to get a number larger than 8 and subtract it down to 8? So subtract down to 6.
4 times 2.
3 times 4 is
12.
12. So 3 times 4 is 12. 3 times 2 is 6. 12 minus 6 is?
6.
So this is going to work out just fine for us. we need to have the 12 be positive because we need to have a positive number as our linear term. So I can go ahead now and say 3x and 3x. I can say that right off the top. I can also say that the positive has to be the 4 because we're multiplying to get a positive 12. And so this leaves 3 here. Excellent.
Equal them to 0.
Now we are on the cusp of getting the answer. I know it's a long problem. I know it's difficult. So we're going to say that to make this equal to 0, one of these two binomials has to equal 0. So let's deal with this one first because it's easier. What are we going to do to both sides to get the x by itself? Add 3. Add 3. So I get 3x is equal to 3. What am I going to divide by 3? Divide by 3. So x is equal to?
0. 1.
Because 3 divided by 3 is 1. All right. So then that's one of our answers.
Minus 4.
So we'll subtract 4 from both sides on the other one. So we have negative 4 is equal to 3x. Now what?
Divided by 3.
So I get x is equal to negative 4/3. And that is my answer. I'm done. I would lie to you. I would say it wasn't really that bad, but I am guessing that you are thinking this was awful. But it was kind of fun.